All right. In this question, we are looking to find a missing equilibrium composition or concentration when we know the equilibrium constant. Now we're given some more information. We're given this information of how many moles of N2 and NO we start with. Now, this doesn't help with how much we have at equilibrium. So we're gonna have to do a lot here. So it's a big problem. We see everything is gases, so that's good. We understand that everything will be included. So we got to do a few things here. We got to write our equilibrium constant expression, and then we got to calculate the actual concentration. We're given moles and we're given a volume, so we can solve for moles per liter, molarity. So let's do that. So let's start out with N2. We have 0.90 moles, and it's per liter, so I'm going to say 0.250 liters, and I get 3.6 molarity. Now, if I switch to NO, I get 1.9 moles per 0.250 liters, and I get 7.6 molarity. Now, again, that's starting point. So we're not just going to write our expression, which we can do. We can write K equals products NO squared. It's got a 2 in front of it into O2. Now we know that K equals 0.191. So we could, we're gonna have to rearrange here, but we can't just put these numbers. I can't put this number in here because it's not the concentration at equilibrium. It's the concentration when I started. So to solve for concentration at equilibrium, I have to use my ICE table. Now that's initial change equilibrium. Now we just write ICE. Now I'm going to essentially write my reaction up over the top. And I'm going to write what I have. So I know I start with 3.6. I have 0 O2. And I have 7.6 molar of my NO. Now, this is interesting, right? I have one of my reactants and my product, but I'm missing one of my reactants, which means at equilibrium, I'm going to have this reaction go here because it's going to try to create one of my reactants. Now, this is different than we've done all year, right? Now this idea that we can go both ways and trying to figure out which way it's going. Well, if I have 0 of one of them, it's going to form that. Now, sometimes that 0 is the product, sometimes it's one of the reactants. And so we are going to add X to this. Now it's a 1 in front of it, so 1X, 1X. Now this, right, I will use twice as much of this to form each one of these. So I'm going to subtract 2X here. And so now I can see what my numbers are at equilibrium. I got 3.6 plus X. Here I have X for O2, and here I have 7.6 minus 2X. Those will be my concentrations. So actually I can plug those in now. So here I have 7.6 minus 2X squared over 3 plus X times X. Now I'm going to bring this side up over here. We essentially have to solve for X. What is X? And then once we solve for X, it asks for what is the molarity of NO. So that's our product. So we're going to have to find the 7.6 minus 2X and figure out what our concentration of NO is. So we still got a ways to go. So let's rewrite this. 0.191, 3.6 plus X equals 7.6 minus 2X squared. Now, there's a bunch of steps. Another way I could write this is to write another 7.6 minus 2X. I got to calculate that out. I got to calculate this side on the left out. I'm going to, I already did these steps, so I'm going to just write that I got 0.688 x plus 0.191x squared, and that equals 57.76 minus 30.4x plus 4x squared. Still, I still got to simplify. So I'm going to bring my x squareds together and my x's together. So I'm going to bring both of these over, subtract them out, and I'm going to get 3.809x squared minus 31.088x. So that was minus subtracted from a negative. So it got larger, and then plus 57.76 equals 0. Now this is quadratic formula, right? I could write it out. I'm running out of room here, but right, you got, I could say x equals 31.088 plus or minus square root of negative 31.088 squared minus 4, et cetera, over 2a, and calculate for the two answers. I can also use a quadratic calculator on the computer, which is I'm going to do, and just type in A, B, and C, and I get x equals 5.301 and x equals 2.860. Now what you'll see is you'll get two answers because of this plus or minus, and what we have to do is figure out which one is legitimate. One of them is going to be, one's not. In this case, it's this 5.301, because if I subtracted 7.6 minus 5.31, so about times 2, 10.6, I'd have a negative amount as my product here, and that isn't possible. I can't convert so much that I have a negative amount of product. So that one is not possible, so I'm going to use this 2.86 as my x. And so then now I could solve for each one of these x's. So this is 2.86. This is 3.6 plus 2.86. And then this one is the one that we care about because it asks to solve for the molarity. So I'm going to say 7.6 minus 2 times 2.86. And I get my concentration of NO equals 1.88 molar. Now the 0.191, now we know it's going left because there's a 0 over here. We also see that the concentrations of this are all higher than this one, which is 1.88. Now this is because we have a K that's less than 1, so it actually favors the reactants, as we talked about. The other thing you can do is if you put in all these numbers here, you know, all the numbers, 3.6 plus 2.86 here, 2.86 here, and our 1.88 here squared, you can see if you get the right answer. You should get 0.191 if you put all those in. So you can do a little check here if you want before you enter your answer. I'm going to go ahead and put my 1.88 molar in here. It says 2 decimal places. It's got the molar for me already. And check. There we go. So lot to it, a whole lot to it. This ice table is a tricky concept to learn. We're going to, so as many of those as you can do, I would write this out. So use a piece of paper. Don't just try to keep it all in your mind, and make sure you're following all these steps as you go through. These ones are long and tough, so work through them.